Writing equations from data. According to the Old Farmer's Almanac, in Las Vegas, Nevada, the number of hours of sunlight in the summer solstice, which is 172 days, is 13.367, and the number of hours of sunlight in the winter solstice, which is 355 days, is 9.667. Therefore, we have 2 points, 1 point being the summer solstice and 1 point being the winter solstice. I can graph those 2 points. This is my summer solstice. This is my winter solstice. The difference between my maximum and my minimum is the same difference between this maximum and this minimum. So if I were to find the difference of my x values here, 355 minus 172 gives me approximately 183 days. I can find the difference between here. So if this maximum is at 172 days, 172 minus 183 gives me a negative 11 days. Therefore, I can graph my function, which approximately looks like my cosine function. Now I can find all of my values for my equation. If I'm saying this is a cosine function and I'm going from minimum to my middle to my maximum, I know it's going to be a reflection, so negative 1/2 times the absolute value of my maximum minus my minimum is equal to negative 1.85. I know this has a vertical shift up, so I'm taking my maximum and I'm subtracting the absolute value of my A, and I get 11.517. That is the pink dotted line on my graph. My B, because we're talking about the number of days, there are 365 days in a year, and because I'm talking about the cosine function, it's going to be 2 pi divided by 365. My shift, I'm saying this is a cosine function. This minimum point is 11 units away from my y-axis. So I'm taking 11 units and multiplying it by my B value, and I get 22 pi divided by 365. Now I have all my information in order to be able to write my equation, which is y equals negative 1/2 cosine times 2 pi over 365x plus 22 pi over 365 plus 11.517. I can use this function to predict the number of hours of sunlight for April 1st, which is the 91st day. Because my x-axis is the number of days and my y-axis is the total number of hours, then I can plug in 91 for my x. So as soon as I plug 91 in for my x, I'm going to put this entire thing into my calculator, and I get approximately 11.425. You can verify that on your graph by finding approximately 91 and seeing if that makes pretty much close sense to what your graph looks like. Then it says use your graph to predict where there will approximately be 12.5 hours of sunlight. So I drew a horizontal line at y equals 12.5. That is the black line in my graph. And I put a point on my graph that touched that horizontal line and estimated that in approximately 111 days and approximately 240 days, the hours of sunlight will be at 12.5.